So good afternoon. This is the numbers 8 and 9 from the worksheet that we're going to be looking at. So the first question, write the K expression for a situation in which there is silver phosphate and ammonia in solution. So we're looking at a KSP here for silver phosphate. We have this, and for the formation of this complex, we have this expression. So since both of them are in the solution, what we're going to do is just kind of take these expressions and push them together. So here it is, right? Your overall K is going to be KSP times KF. Point out, this is going to end up being cubed. So we got to look at this expression. So how do we get it? Well, all right, we're going to ignore this because it's a solid. Everything else is aqueous. So we've got silver ions, concentration of silver ions, that's cubed because of the coefficient there, concentration of phosphate, and our last product, so this has cubed, we're going to get to that in a second. So we've got this, but there's no coefficient here, so that initially did not have a 3 there. Then we've got this, which is our silver ions on the reactant side. Again, that did not initially have a 3 there. And then we've got ammonia, and there was a 2 there. So, well, why are we cubing it? We're cubing it so that these silver ions are going to end up canceling out. Because if they are present, they are going to, and the ammonia is present, they are going to form this. So what we do is we end up cubing everything in this expression. So we take our silver, that gets cubed, right? There's no coefficient here. We're putting it here so it matches this, and this is going to fall out. The ammonia, there's a 2, now it's a 6, and over here, now it's a 3. All right, that's easy. So KSP value, 1 times 10 to the negative 16th. This one's given to you. KF value, 1.7 times 10 to the 7th. That's cubed. Overall, you get a K value of 5 times 10 to the 5th. All right, now we're getting into question number 9. So number 9, we have if 225 milliliters of 0.125 molar NH3 are mixed in with, it's 150 milliliters of this other solution, how much silver phosphate is going to dissolve? So we're going to use this expression. Right? This is the equilibrium that will be established after we put the ammonia in, right? And this complex is formed. So we have this value. I showed you how we calculated that. And this is our expression after the silver ions are omitted. All right, so we know we have phosphate here, we have this complex, and we have ammonia. We are looking for how much of the silver phosphate is going to dissolve. If we're going to find that, we need to know something about the solubility of silver phosphate. So the solubility, that's in moles per liter. So S equals, that's what we want to know. If we find that, we can answer this question. So we know that S, right, if we have 1 mole of silver phosphate dissolved, then we're going to have 1 mole of phosphate dissolved. So whatever S is, that's equal to this concentration. So that's S. Over here, if we have 1 mole of silver phosphate dissolved, we do know that we are going to have 3 moles of silver ions dissolved. So that's a 3S. Right, so we've got S here, we've got 3S here, 3S cubed. So S times 3S cubed, that's for our product side. As far as ammonia we can relate to this complex. If there are, let's see, 3S moles of this complex, there will be 6S moles of ammonia. So 6S moles of ammonia must be here. Now, so they came from the reactant side. So we're going to have some initial amount of ammonia, and then 6S moles are going to go here. So that's this expression. I just wrote an I there. So initial ammonia concentration minus 6S, and that is all to the 6th power. If we do the math, we have 225 milliliters of ammonia, 1.125 molar. So we figure out how many moles we have. I'm dividing this by 0.375. That is the total volume of the solution. We want the molarity of the ammonia. So times the volume that it came in divided by the total volume of the solution. That's what this is. So those liters cancel. Yeah, moles per liter. Sorry. Okay. 0.0833 molar initially. All right. So we substitute. We got. Or I put everything in. This value 27s to the fourth. On the bottom 0.0833 minus 6s to the sixth. If you solve this, and your calculator can handle it, you're going to get S equals 0.0109 moles per liter. So I did write the states of matter here. I drew a line here because that's S. This is S right here. That's aqueous. Right? That's how much is actually going to dissolve, regardless of how much silver phosphate you actually put in there. So, okay, that's 0.109. What I'm going to do, so that we can answer the question. The question is, how much silver phosphate dissolves? So if we're thinking about how much dissolves, we really could answer this question in moles, but usually we're probably talking about grams. How many grams of silver phosphate are going to dissolve? Well, this is moles per liter, so we convert moles to grams. All right, we're going to have some number of grams that can dissolve per liter. If we multiply by the volume of the solution itself, we're going to end up with 1.71 grams of silver phosphate. And that is number 9.